Hi everyone, this is Rana Sir. Welcome to our RANA SIR educational channel. Today I will talk on a topic whose name is Law of Conservation of Linear Momentum. On this topic I will solve some numericals, and that numerical is important. So in this numerical I will apply the application of law of conservation of linear momentum. Therefore, you concentrate on this live video from starting to end. To develop your knowledge on this point, that is, in other words, we can say that first of all, you have to also take one notebook and one pen, and then you have to sit at your location properly, positively, and safely to write all data which are written on the blackboard, and also those informations which will be spoken by me. Okay, students, so positively I will explain it. First of all, you like this live video, and also you share this live video with your colleagues, friends, and students, so that they can also update their knowledge on this topic. Simultaneously, you also subscribe this educational channel more and more. Okay, students, so positively I am going to write one numerical, and then in that numerical I will use the concept of law of conservation of linear momentum. So you look at positively. Okay, students, so first of all I am going to explain all these informations, and I will apply the concept of law of conservation of linear momentum in this question. Okay, so first of all I am going to writing the concept law of conservation of linear momentum. Law of conservation, CONVER, conservation, CONVER, conservation. Conservation, CONVERSATION, conservation of linear momentum. Law of conservation of linear momentum. So this concept I will use one numerical, and that numerical I am going to explain. First of all I will draw its diagram, and then I will write its question. Now one object which is a label as, suppose that this is a object and this object has mass, suppose that 0.5 kg. This mass, this object has mass 0.5 kg. Now I will say this is the mass m. Now it is collide with a object that is hanged with a string, and in that object some sand materials are available. Now we have to calculate the force which is exerted by this object on the a bag of material, and that bag material has sand. So I will say this is a bag and which has sand inside it. There are sand inside the bag material, sand bag. This is a sand bag. Now this object is going so suppose that I will say this is the object and this object is going from this point, and that object is inserting inside the sand bag. Suppose that that is available inside the bag like this. So we have to get force which is exerted by this object on the sand bag. So I will say this object has mass this one and it has initial velocity. Suppose that here I am going to take 100 centimeter per second. Okay, now I will say this sand bag has mass m is equal to 7.5 kg. I will write this is the mass m1 of this object, and this is the bag mass m2, that is the second object, 7.5 kg, that is available in MK system. Now this is the mass of this object which has mass 0.5 kg and it has initial velocity 100 centimeter per second. Now this object is inserted inside the sand bag, and this object exert a force on the sand bag. We have to find that force, okay, by this object. Okay, so this is the diagram. There is one object whose mass is m1 and another object, that is the sandbag. Mass of this sandbag is m2 whose actual value is 7.5 kg, that is available in CGS MK system. Okay, now this m1 is also given in MK system, and the velocity of this object that is given in CGS system, that is centimeter per second system. Okay, so we have to utilize all these data in one system, either in MKS system or in CGS system. Otherwise, if I will not calculate, so a transfer from one unit to another unit, so after solving its solution will be wrong. So we have to put in one system, so solution will be correct either in MKS system or in CGS system. First of all, I am going to write its actual question, and after writing its actual question, then I will use the appropriate solution of this question to get the destination information. Okay, students, so you concentrate on this topic. I'm going to write its question here. So here I'm going to write, there are two masses. There are two masses whose actual values are are whose actual values are 0.5 kg and another value is 7.5 kg respectively. Okay, now one object is bullet. Here I have to explain one object is bullet and another object is here I will write properly. Another object is sandbag. So before collision, so after collision, bullet is exerting a force on sandbag. We have to calculate that force. So after collision, COLLISION, after collision, bullet is exerting a force on sandbag. We have to find that exerted force. Here, find या calculate the exerted force. Find the exerted force by bullet on sandbag. Okay, students, so here I have taken two objects. One object is bullet and other object is sandbag. So here I have to write its name is bullet. Okay, you concentrate here to understand this question clearly. Before the momentum, we have to calculate its value will be m into u. So this is the momentum before the collision and this is the after collision, because this bullet has mass m1 and velocity u, and this bag has mass m2, but it is going opposite direction. It is moving in opposite direction and this bullet is moving in forward direction. So after inserting into the bag this bag and also this bullet each moving in backward side direction. So we have to calculate that velocity, which is obtained by this sandbag and also with bullets. Okay, we have to also calculate this one, and also we will also find the velocity of sandbag which is moving in opposite direction of the bullet. Okay, so another question can be also asked here, that can be like this way. So we have to find out the velocity of with bullet. We have to find out the velocity of sandbag with bullet. It means that before collision there is no any extra momentum. That is, we have to calculate momentum. In other words, that is P is equal to m1 into u. This is the momentum before the collision. But after the collision, this bullet will insert inside the sandbag. So after inserting, it will stop there. So final velocity will be 0. But that sandbag and with the bullet, it will backward direction, in forward direction. So after collision, both objects will have different masses, because according to linear conservation of linear momentum, which is equal to m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. So these are the informations. So all these informations we have to use here, because if two objects will be before the collision, so we will write the momentum of each and every object separately, and then we will add all momentum before the collision. So after collision, because mass will be same, but velocity can be changed. Either it will be 0 or it will be something more than the initial velocity, it will be minimum with the initial velocity. So velocity will change, but mass will be same. First object will also have same mass, second object will also have same mass, but velocity of each and every mass can be changed immediately. Okay, so students, so I have to use here law of conservation of linear momentum, because in this case I will calculate before the collision, and after the collision I will use the concept of law of conservation of linear momentum, and then we will use that concept and we will find its information that is asked in the question. If any object which has external force 0, it means that momentum will be constant, and of that system energy of that system will be constant. It means that there is no any change in data or information of the system, because momentum is constant, so there is no change in data of the system or any information of the system. That is, in other words, we can say that energy will be constant of whole system. Okay, students, so very important topic, law of conservation of linear momentum. So we have to use this concept to solve the written numerical and also shown in the figure, information shown in the figure. Okay, student, so all these information I will also translate into in Hindi, so student who are reading in Hindi medium, those student can also understand its concept in detail, okay, and also clearly. Okay, student who are reading in CBSE board or UP board, those student can also understand its concept clearly. Okay, because here all information of the question I have already explained. Now I am going to translate all these information into in Hindi, so student who are reading in Hindi medium or in UP board, those student can understand its concept clearly. Okay, यहाँ कहा गया है कि दो ऑब्जेक्ट है ऑब्जेक्ट का मतलब मीनिंग होता है वस्तु। वस्तु का मीनिंग ये होता है जो भी हम अपनी आंखों से देखते हैं उस सभी इंफॉर्मेशन को, सभी थिंग्स को हम एक ऑब्जेक्ट के नाम से, वस्तु के नाम से, या पिंड के नाम से, या कण के नाम से जानते हैं। तो एक कण जो होता है हमारा बुलेट है, बुलेट एक टर्म है, एक बुलेट है। इस बुलेट को जो होता है एक सैंड बैग है, एक बैग है जिसमें सैंड भरा हुआ है, और उसको जो होता है एक रिजिड पिंड से, एक छत के सहारे, इसके एक पेड़ से, रस्सी से उसको हैंग कर दिया, लटका दिया गया है। अब जो होता है किसी पिस्टल से जो होता है इस बुलेट को जो होता है फायर किया जाता है, तो इस बुलेट का मास जो होता है कितना है, 0.5 kg है, और इस ये मूव करेगा, उसके लिए वेलोसिटी दिया गया 100 सेंटीमीटर पर सेकेंड, 100 मीटर पर सेकेंड। चूंकि यहाँ पर मास जो होता है एमके सिस्टम में दिया गया है और वेलोसिटी जो होता है सीजीएस सिस्टम में दिया गया है, इसलिए इसमें ध्यान स्टूडेंट को कंसंट्रेट करना है कि पूरे सिस्टम में, पूरे क्वेश्चन में जो यूनिट्स होंगे, जो भी डाटा होगा वो उस डाटा का यूनिट होगा, या तो एमकेएस सिस्टम में रहेगा तब हम सॉल्व करेंगे उसके सॉल्यूशन को, उस सॉल्यूशन को फाइंड आउट करेंगे, या तो सीरियस सिस्टम में रहेगा तभी जाके उसका सॉल्यूशन हम कर सकते हैं। अगर ऐसा नहीं है तो उसको हम कन्वर्जन करेंगे, और जब कन्वर्जन करेंगे उसके बाद से उसको हम इजीली सॉल्व कर सकते हैं। तो एक बुलेट का, इस बुलेट का मास दिया गया, उसका वेलोसिटी दिया गया, इनिशियल वेलोसिटी दिया गया, इनिशियल वेलोसिटी को हम प्रारंभिक वेग से नाम से हम जानते हैं। ओके, नाउ दूसरा ऑब्जेक्ट है, ऑब्जेक्ट मतलब वस्तु या पिंड है या वस्तु है। उस वस्तु में जो होता है, हमने एक बैग लिया, वो सैंड बैग है, उसमें सैंड भरा हुआ है। जब पिस्टल से जो होता है हम इस बुलेट को जो होता है फायर करते हैं तो उसमें आकर धस जाता है। धस के वो जो होता है एक किसी वेलोसिटी से जो होता है, दोनों जो होता है किसी वेलोसिटी से क्या कर रहे हैं, मूव कर रहे हैं। तो कोलिजन के पहले जो होता है वेलोसिटी और मास में कोई चेंज नहीं होता है, लेकिन कोलिजन के बाद जो होता है मास तो सेम ही रहेगा, लेकिन उसका वेलोसिटी चेंज हो जाता है। उसका वेलोसिटी मींस वेग, वो वेग चेंज हो जा सकता है, या तो ज्यादा हो जाएगा इनिशियल वेलोसिटी से, या उससे कम हो जाएगा, या उससे उससे कम हो जाएगा, या उसका जीरो हो सकता है। ओके, तो ये इंफॉर्मेशन कोलिजन के बाद हो सकता है। इसलिए लीनियर कंजर्वेशन ऑफ लीनियर मोमेंटम कहता है कि अगर हम उस ऑब्जेक्ट का कोलिजन के पहले मोमेंटम कैलकुलेट करेंगे और कोलिजन के बाद मोमेंटम कैलकुलेट करेंगे, वो दोनों मोमेंटम का वैल्यू जो होता है सेम होता है। इसका मीनिंग ये होता है कि अगर किसी ऑब्जेक्ट पर अगर एक्सटर्नल फोर्स नहीं लगता है, इसका मीनिंग ये होता है कि उस ऑब्जेक्ट का पर जो उस ऑब्जेक्ट का मोमेंटम जो होता है कांस्टेंट होता है। इसका मीनिंग ये होता है कि उस मोमेंटम मीन्स उस सिस्टम का टोटल एनर्जी जो होता है कांस्टेंट होता है, सेव हो गया है। इसका मीनिंग ये, दूसरे शब्दों में ये कह सकते, कोई डाटा लॉस नहीं हुआ है। इसका मीनिंग दूसरे शब्दों में ये भी कह सकते हैं कि उस सिस्टम का जो इंफॉर्मेशन है वो इंफॉर्मेशन लॉस नहीं हुए। इस तरीके से हम जब इस मोमेंटम कांस्टेंट रहता है तो हम इस तरीके के इंफॉर्मेशन एक्सप्लेन करते हैं। तो कोलिजन के पहले मोमेंटम कैलकुलेट करेंगे और कोलिजन के बाद मोमेंटम कैलकुलेट करेंगे। दोनों मोमेंटम कैलकुलेट करने के बाद से हम कहेंगे अकॉर्डिंग टू लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम, लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम। इसका मीनिंग यह होता है समवेग संरक्षण के नियम से या समवेग संरक्षण के सिद्धांत से जो कोलिजन के पहले, टक्कर के पहले जो मोमेंटम था, जो समवेग है, वो दोनों समवेग क्या होता है, बराबर होता है। इसका मीनिंग ये होता है उस सिस्टम में कोई भी डाटा का लॉस नहीं हुआ है। ओके स्टूडेंट्स, सो ऑल दीज इंफॉर्मेशंस आई हैव रिटन हियर। ओके, इफ यू हैव एनी डाउट, सो यू write your doubt point in the comment section, या type your information in the comment section and send positively which is related to this topic, and then you ask. If you will ask, then after sending, so I will read your sent information positively, and then I will give the appropriate solution of your question in detail. If you are understanding, so you like this live video, and also you share this live video with your colleagues, friends, and students so that they can also update their knowledge on this topic. Okay, students. So positively, I am going to erase, and after erasing, I will explain its value here, its solution in detail. Okay, student. So all these informations I will explain in detail. Okay. Now, so positively I am going to erase it, and after erasing, and I will write the concept of law of conservation of linear momentum, and then I will solve with the help of law of conservation of linear momentum of this question. Okay. So positively I am going to erase. After erasing, there is no space, therefore I am going to erase, and then after erasing I will provide its appropriate solution. So you concentrate here. If you have any doubt or any query, so you type your information positively in the comment section, and then you say, after looking you, I will give the appropriate solution. Okay. Now here I am going to write according to law of conservation of linear momentum. Suppose that there are two objects. Here one object I am going to say this is a object, and which has mass m1. Okay. And it has also velocity u1. Suppose that another object I am considering, it has mass m2. It has mass m2, so its velocity is also u2. So this is the information, this is the information which is going, this is the information which is going along this side. Okay. So this object is moving along this side, and this object is moving along this side. So after some time both objects will meet at a point, and both objects will collide. It means that both objects will collide each other after collision. I will say both objects will have same mass m1, and its velocity will be v1, and its mass will be same m2, and its velocity will be also v2, because there is no change in mass. But velocity can change. Okay, student. If one object which has mass m1 and its initial velocity is u1, and other object which has mass m2 and its velocity is u2. Similarly, I have taken, because this object is moving forward direction, and second object which is moving in backward direction, so at a instant of time both objects will collide each other. So this is the information before collision. I will write, this is the information before collision, before collision, and this is the information after collision. So these are the information before collision, these are the information after collision. But according to law of conservation of linear momentum, we have to write its concept like this. That is, here I will write m1 u1 plus m2 u2, which is equal to, I have to write here m1 v1 plus m2 v2. So here I have to write m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. So this is the concept of law of conservation of linear. So before collision, I have to calculate the momentum of first object and also momentum of second object, and then I will add these two momentum before the collision. Now in second figure, I will also calculate momentum of first object and also momentum of second object, because after collision each and every object will change its velocity. Velocity can be maximum, yeah, can be minimum, or can be zero according to the situation. If situation will be critical, so according to situation it will change its velocity. It can be maximum, minimum, or zero. Okay. So collision I am before collision I have calculated its momentum, and after collision I have also calculated its momentum. So both momentum will be equal. So this concept I will use in this problem, is in this numerical, to calculate its value. Okay, now I hope that each and every students are understanding this concept. Okay, so this concept you have to utilize, because here there, before collision there is only one mass. It means that its momentum I will calculate m1 into u, but u is given in centimeter CGS system. I will convert this information into MKS system. Okay, so I hope that I know this CGS system. I will change in MKS system. So how we will change this value into MKS system? So I'm going to explain here. Okay, so each and every student who are not understanding, so all these information those students need to write on your notebook for further revision. You have to take one object whose name is, here I am going to say this is the object A and this is the object B. So object will be same A and object will be same B, but its velocity will change only, because object A has velocity u1, object B has a velocity u2. Similarly, after collision there is no change in mass, only velocity will change. So object B will have also same mass, but velocity will change. Okay, so this information, all these informations I will also explain into in Hindi, so students who are reading in Hindi medium, those students can understand it. Okay, यहाँ कहा गया है कि लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम, इसका मीनिंग ये होता है रेखीय संवेग संरक्षण का सिद्धांत। रेखीय संवेग संरक्षण का सिद्धांत होता है क्या? सपोज कीजिए कि हमने दो वस्तु लिए हैं, एक वस्तु का नाम ए है, दूसरी वस्तु का नाम बी है, और ए वस्तु का मास जो होता है m1 है और इसका वेलोसिटी जो होता है e1 है। इसी तरीके से दूसरा ऑब्जेक्ट है बी, उसका मास m2 होता है, उसका वेलोसिटी जो होता है u2 है। तो हम पहले ऑब्जेक्ट का मोमेंटम कैलकुलेट किए, m1 u1 है, अब दूसरे ऑब्जेक्ट का मोमेंटम हम कैलकुलेट किए हैं m2 और u2 है। अब दोनों मोमेंटम को जो हम ऐड किए हैं, ऐड करने के बाद से जो होता है, हम राइट हैंड साइड में भी कोलिजन के बाद जो होता है, जो ऑब्जेक्ट है उसका मास सेम ही होगा, m1 होगा, और उसका वेलोसिटी चेंज हो जाएगा। उसका वेलोसिटी या तो ज़्यादा होगा या उसका वेलोसिटी कम होगा या उसका वेलोसिटी 0 हो सकता है। उसी तरीके से मास बी है, उसका भी मास तो सेम ही रहेगा। ऑब्जेक्ट बी है जो उसका मास सेम रहेगा, लेकिन उसका वेलोसिटी क्या होगा, चेंज हो जाएगा। या तो उसका वेलोसिटी ज़्यादा होगा या कम होगा या 0 हो सकता है। तो लेफ्ट हैंड साइड में यह जो इस लाइन के लेफ्ट में है, इसको लेफ्ट हैंड साइड कहें। लेफ्ट हैंड साइड में जो भी डाटा, जो भी ऑब्जेक्ट मीन्स मास है, द्रव्यमान, मास को हिंदी में द्रव्यमान कहते हैं, उसका मोमेंटम कैलकुलेट करेंगे, दूसरे वस्तु का मोमेंटम कैलकुलेट करेंगे, दोनों को ऐड करेंगे। इसी तरीके से कोलिजन के बाद से हम मोमेंटम अलग अलग ऑब्जेक्ट को कैलकुलेट करके ऐड करेंगे। तो लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम, इसका मीनिंग ये होता है कि संवेग संरक्षण के सिद्धांत से कोलिजन का हिंदी होता है टक्कर। टक्कर के पहले का मोमेंटम और टक्कर के बाद का संवेग, दोनों संवेग क्या होता है, आपस में बराबर होता है। इसका मीनिंग ये होता है कि उस सिस्टम में किसी भी एनर्जी का लॉस नहीं हुआ है। दूसरे शब्दों में कह सकते हैं कि उस सिस्टम में कोई भी इंफॉर्मेशन या कोई भी डेटा का लॉस नहीं हुआ है। इसका मीनिंग यह होता है कि उस ऑब्जेक्ट पर कोई भी एक्सटर्नल फोर्स नहीं लगा है। ओके स्टूडेंट, सो ऑल दिस इंफॉर्मेशन आई विल यूज इन द written question and also in the drawn diagram, and then we will find the appropriate velocity when after collision both objects will move with a same velocity. Okay, so these informations which are written like as object A, object B, this is the information before the collision, and A and B when both object collides. Both object collide and after collision this figure is drawn here, so that these two figure I will use all concept in the written question, and then after using, and then we will find the common velocity of the sandbag and with bullet. Okay students, so you concentrate here. I am going to find out its solution. Okay, now I will use the concept of law of conservation of linear momentum. So this formula I will not erase. So here I am looking, before collision there is only one mass, but first of all I will change unit, because one mass object of first object has mass in kg, that is in mk system, and second information which is given in cg system. So second information I will change in mk system. So I will write here solution. First of all I have to write here solution, and after writing solution I will write here given that what is the information that is given, and that information I will write here positively. So given that, so here I will write u, which is equal to 100 centimeter per second. 100 centimeter per second is given. Now here I can write 100 into 1 centimeter per second I can write. Now here I will write in the place of 1 centimeter. So in the place of 1 centimeter I can write 0.01 meter per second is available. So when I will multiply these values, so after multiplication I will get 1 meter per second. So 100 centimeter per second is given. So I will change in MK system, so that will come centimeter can be converted into meter. So 1 centimeter which is equal to 0.01 meter. So already I have written here. So after multiplication of 100 into 0.01, so after multiplication I will get 1. So 1 meter per second. This is available in MK system. Now here this is available in CG system. CG system. So centigram second system, centimeter gram second system, and this is coming in system, that is meter kilogram second system. So student need to solve all data in either in MK system or in CJ system. There is in information there is required information is that you have to follow in one system to calculate, and after calculating you check its answer is given in MKS system, CGS system. According to the answer you can change again from MKS to CGS or CGS to MKS system, but during the solution you have to put in one system. Okay students, so you have to follow it clearly. Okay, so mass is available in MK system, and velocity I have already calculated in MK system, and second object, that is sandbag, that is given in MK system. So all informations are available in MK system. So I will use the concept of law of conservation of linear momentum, and then we will solve it. Okay, before collision there is one object. So one object I will take here, m1u, and m2 is not available, so this term will be 0. But here this one object is available, that is bullet, so its velocity is m1 and v. So because after collision its velocity will change, so I have taken here both object will move with its common velocity, so that common velocity we will use there. Okay, so this information here I am going to save, because u is equal to 100 centimeter per second, but after conversion I have got its value 1 meter per second. Okay, so here there is no space, so we have to further erase it, and after erasing I will give its final solution. Okay students, so you concentrate here. If you are getting any trouble or any query, so you type your query in the comment section positively, and then you send. After sending I will receive, after receiving I will give the appropriate solution of your question in detail. Okay student, now if you are understanding all these information clearly, so you like this live video, and also you share and students, so that they can also update their knowledge on this topic. Okay, now if you simultaneously you also subscribe this educational channel more and more. Okay, now I am going to erase above data, and then how we have to use the concept of conservation of linear momentum. So before collision there is one mass, so one mass that is available m1. So I will write m1. Now u is able in the place of u1, I have to write u, and there is no second mass before collision. I will put its value is 0. Now mass of second or first object will have same mass, that will be m1, and now both object after collision, both objects are moving with same velocity, so I am going to write that velocity is v. So I will write here m1 plus v, and second object has mass m2, so I will put here m2. So in the place of m1, I have put there m1, and in the place of v, because both objects are moving with the same velocity, so I have let here velocity is v, that is common for both objects. So sandbag has mass m2 and its velocity is also v, because with same velocity both are moving. Okay, so this formula I have used in this numerical for getting its common velocity. So this term is available, I have written here. Now this term means second object is not available before the collision, so its value will be 0. And now first object I have written its momentum, and second object of momentum I have written, because both object after collision moving with a common velocity, so I have taken common velocity is v. Okay, further I will simplify. Now there are two terms on the right hand side, so in each term v is common. Okay, so I will take its value, v is common, so in the bracket I have to write here em1 plus em2. Okay, any doubt? If you have any doubt, so you can ask your query in the typing in comment section, and then you have to send. After sending, I will reply the appropriate solution positively. Okay, now so value of m1 is also available here 0.5 kg, so here I have to put 0.5, and in the place of u I have converted 100 centimeter per second, that is 1, so I have to put there 1. So after simplifying, I will put 5, and here velocity we have to calculate v. Now the value of m1 is given 0.5 kg. Okay student, if you have any doubt, so you ask your doubt by typing. Okay, so value of m2 is given 7.5, so I have to put here 7.5, and then we will calculate it. Okay, so down formula that is written, law of conservation of linear momentum, I have to erase it, and after erasing I will simplify this value. So here I will add. So for addition I will write here positively, that is 7.5 plus 0.5. After adding, I will say here 5 plus 5, that will be 10, 0, carry will be 1, 7 plus 1, 8. So I have to put here 8 kg, that is 8.0 kg. Okay, positively I have to put. Okay, now here I will say 5. So further I will get its value. So this is the right hand side data, and this is the left hand side data. I will further simplify. All data which are available in the right hand side I will put in the left hand side, and all data from the left hand side I will put in the right hand side. So there is no any change in the solution. Okay, so I will use this, and after using I will get the value of v. That will be the answer of my question. Okay student, so all these informations I will also translate into in Hindi, so student who are reading in Hindi medium, those students can understand all these informations clearly. Okay, now कि जो linear momentum है m1 u1 plus m2 u2, after collision m1 v1 plus m2 v2 होता है। इसका मीनिंग ये होता है कि कोलिजन के पहले ऑब्जेक्ट का जो द्रव्यमान है और दूसरे ऑब्जेक्ट का द्रव्यमान, कोलिजन के बाद भी जो होता है उसके द्रव्यमान में कोई चेंज नहीं आता है। ओके, अगर कोलिजन के बाद से अगर उसका मास छोटा छोटा हो जाएगा, सभी मास को कलेक्ट करेंगे तो पूरा मास हमको मिलेगा, तो मास में कोई परिवर्तन नहीं होता है। लेकिन जब कोलिजन के पहले का वेलोसिटी कुछ और था, वेग और था, और कोलिजन के बाद वेग और दूसरा हो जाएगा, या तो कोलिजन के बाद उसका वेग बढ़ जाएगा इनिशियल वेग के रिस्पेक्ट में, प्रारंभिक वेग के रिस्पेक्ट में, या प्रारंभिक वेग के रिस्पेक्ट में जो होता है उसका वेग कम हो जाएगा, या तो जीरो हो जाएगा। वह अकॉर्डिंग टू सिचुएशन डिपेंड करेगा, कैसा सिचुएशन उसी के अनुसार उसका वेग चेंज होता रहेगा। तो उस कंसेप्ट को मैंने यूज किया था। तो कोलिजन के पहले हमने देखा था कि एक ऑब्जेक्ट है और उस ऑब्जेक्ट का मास जो होता है 0.5 केजी दिया गया था, 0.5 केजी, और उसका वेलोसिटी वेग जो होता है 100 सेंटीमीटर पर सेकेंड जो सीएस सिस्टम में दिया जाता है। जब कन्वर्ट किए थे तो 1 मीटर पर सेकेंड पाए, इसलिए 1 यहाँ पर रखे। लेकिन कोलिजन के पहले कोई दूसरा ऑब्जेक्ट नहीं था, तो इसलिए इस वैल्यू को जो सेकेंड मोमेंटम है उस सेकेंड मोमेंटम की जगह पर मैंने जीरो को यूज किया। ओके, अब कोलिजन के बाद जो होता है दोनों ऑब्जेक्ट का मास जो होता है सेम ही रहेगा, लेकिन उसका वेलोसिटी जो होता है चेंज हो जाएगा। हो सकता है कि दोनों ऑब्जेक्ट मिलकर एक वेलोसिटी से मूव करेगा, या दोनों ऑब्जेक्ट जो होता है अदर अलग अलग वेलोसिटी से मूव करेगा, या दोनों ऑब्जेक्ट या वस्तु का जो वेग होगा वो जीरो हो जाएगा। वो अकॉर्डिंग टू सिचुएशन डिपेंड करेगा, कंडीशन पर डिपेंड करेगा। ओके, तो इस इंफॉर्मेशन को मैंने यूज किया, यूज करने के बाद से m1 m2 को यहाँ पर दोनों टर्म में भी जो होता है कांस्टेंट है। इसका मीनिंग ये होता है कि दोनों ऑब्जेक्ट जो होता है एक कांस्टेंट वेलोसिटी से एक फिक्स वेलोसिटी से मूव किया, वो फिक्स वेलोसिटी के वैल्यू को हमने कैलकुलेट किया। तो पहले टर्म में जो होता भी कॉमन है, पहले टर्म में भी सेम है और दूसरे टर्म में भी सेम है, इसलिए भी जो तक हमने कॉमन लिया है। यहाँ पर बचा पहले टर्म में m1 बचा, दूसरे टर्म में m2 बचा, दोनों के मास को हमने ऐड किया। ऐड करने के बाद से 1 केजी फाइंड आउट किया, और इसका जब मल्टीप्लाई 0.5 से 1 से किया तो 0.5 मिला। अब ये जो इक्वल के लेफ्ट में लेफ्ट हैंड साइड डाटा कहा जाता है, इक्वल के बाद में राइट हैंड साइड डाटा को कहते हैं। अब राइट हैंड साइड का टोटल डाटा लेफ्ट में रखेंगे, लेफ्ट हैंड साइड का टोटल डाटा राइट में रखते हैं। इस तरीके से करने पर किसी तरह का हमारे क्वेश्चन में चेंज नहीं होता है। ओके, that you are understanding all these informations clearly. Okay, now further I will get the value of b properly, what will be the actual value of b. Okay, now above data I will erase, and after erasing I will find its solution. Okay, now I am going to explain how I am going to get its solution. Okay, if students who are getting its solution clearly, so you like this live video and also you share this live video with your colleagues, friends and students, so that they can also their knowledge on this point. Okay, yeah, this topic. Okay, and simultaneously you also subscribe this educational channel more and more. Okay, so above data I'm going to erase, and after erasing I will get its final solution. Okay, now here right hand side data I will put in the left side, so I can write here 8v, which is equal to 8v, which is equal to, here I will write 0.5. So further I will say v is equal to 0.5 divided by 8. Okay, further I will simplify. So after before simplify I will put here 1, I will multiply 100 by 100. So above will be 50 and divided by 8 into 100. I can put here. Okay, so further I will divide 50 by 8, and after division I will divide with 100 also. Okay, so I am going to divide 50 8 8 for 40. So here will be, so here I will say 8 for 50, 48, 40, 8 6 are 48, so I will subtract 10 minus 8, that will be 2, so here will be 0. So I will say 8 2 ja 16, so carry will be 4, 8 5 5 ja 40, 8 5 ja 40, so it will be same. So after simplification I can write that is 6.25 and again divided by 100. Okay students, so this calculation I am going to erase because I have calculated its value, that is 6.25. so v is equal to 6.25 divided by 100. So again numerator value will be divided by 100, so that is very simple. Now from the left hand side, above data I will write here, above data I will write 2 5 6 to 5. Now this point will move this direction 2 digit, so one digit 6 is available, so I will put there 0 because there is no any value, so I can put there 0. So after decimal place there is no any value, so I will put there 0. So v is equal to, so here I will write finally v is equal to 0.0625 meter per second. It is coming in MKS system. Okay, this is the final answer of this question. Okay student, so I hope that its solution you are knowing properly and clearly. If you have any doubt, so you write your doubt point in the comment section positively and then you send. And after looking your issue, I will issue related to this topic, I will give the appropriate solution of your question in detail. Okay, and if you have no any doubt, so you like this live video and also you share this live video with your colleagues, friends and students, so that they can also update their knowledge on this topic. Okay, and always I will meet with you on the same time, that is 30 minutes past to 7 o'clock to 8 minutes 30 minutes past to 8 o'clock. During this time slot always I will be present with you. Okay student, so you have to follow this time slot daily, and during this time slot I have to explain the concept and numericals of class 11 physics in English medium and also in Hindi medium. Okay, and this is also based on NCERT pattern. One statement that is thought I have written and you have to follow it positively, that is written clearly. You look the blackboard and then you understand the meaning of each and every term. That is very important, that will enhance your future. Okay, learning never stop, learning never stop. I have added here one instruction, information, keep always learning. It means that learning never stop, you have to keep always learning, you have to follow this information positively. Okay, so according to this way, the written solution, written question I have solved properly by using the concept of law of conservation of linear momentum. Okay, if any system which has not feeling any external force, it means that there is no any loss of energy of that system. Okay, in other words, say that there is no any change in information of the system. Yeah, there is no any change in the data of that system. Okay, you have to follow it positively. Thank you for watching this live video. I will meet with you on the same day tomorrow. Okay, Jai Hind, Rana sir.